The morning of April 15th, 1943, south of Dieppe, Captain James Goodson banks his P-47 Thunderbolt into a tight turn, eyes scanning the sky through the rectangular windscreen that frames his vision like a prison cell. 8,000 feet below, the French coastline cuts a grey line through the English Channel mist. Behind him, somewhere in the blind sector his razorback canopy creates, death approaches at 400 miles per hour. The Focke-Wulf 190 materializes not from above or ahead, where Goodson's trained reflexes expect threats, but from his 6 o'clock position. The blind spot, the killing zone. German 20mm cannon rounds punch through his Thunderbolt's tail section before his wingman's desperate radio warning reaches his ears. The massive P-47 shudders, metal screaming as explosive shells tear through control surfaces that moments earlier responded to his touch with mechanical precision. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Goodson fights the controls, feeling the hydraulic resistance fade as fluid pressure bleeds from shattered lines. His hands move with practiced efficiency, trimming the crippled aircraft for straight flight, nursing the wounded juggernaut toward the channel crossing that represents survival. Through his windscreen, the clear air offers perfect visibility forward and upward. Behind him, where the tall razorback fuselage rises from the cockpit to the vertical stabilizer, exists a cone of darkness that no mirror can adequately penetrate, no amount of neck craning can overcome. The fundamental flaw in his aircraft's design becomes devastatingly clear. The Republic P-47 Thunderbolt, America's heaviest single-engine fighter, carries 8 50-caliber machine guns, armor protection that can stop German cannon shells, and a Pratt & Whitney double Wasp engine producing 2,000 horsepower. What it cannot provide is the ability to see the enemy approaching from behind. That simple deficiency, measured in degrees of blocked vision rather than pounds of explosive payload, determines who lives and who dies when German fighters attack from the rear quarter. Goodson coaxes his damaged Thunderbolt across the channel, the Pratt & Whitney radial engine running rough but maintaining power, the severed hydraulics reducing his control inputs to educated suggestions rather than commands. He lands at the forward airfield at Manston, the massive fighter settling onto the runway with the grinding protest of overstressed metal and collapsed hydraulics. Ground crews swarm the aircraft, counting holes, cataloguing damage, shaking their heads at wounds that would have destroyed lighter fighters. But as Goodson climbs from the cockpit, his hands still trembling with adrenaline, the tactical assessment overshadows any appreciation for the Thunderbolt's legendary toughness. The aircraft brought him home alive, absorbed punishment that should have been fatal, demonstrated every virtue American engineering could design into a fighter aircraft, except the single most critical capability in air combat, the ability to see death before it kills you. 3,000 miles west across the Atlantic, in a drafting room at Republic Aviation's Farmingdale facility on Long Island, Alexander Kartveli stares at combat loss reports that arrive with increasing frequency from the 8th Air Force bases scattered across England. The designer who created the P-47 Thunderbolt from first principles understands aircraft performance in terms of thrust-to-weight ratios, wing loading calculations, and power plant efficiency curves. The mathematics that govern his profession speak a precise language of forces and tolerances. But the reports from combat squadrons introduce variables that resist mathematical solution. Pilot accounts describe German fighters materializing behind razorback Thunderbolts without warning, attacking from angles the American pilots cannot observe until cannon shells announce the enemy's presence. The tall fuselage spine that Kartveli designed to accommodate the turbo supercharger ducting and provide structural integrity creates a blind sector extending roughly 60 degrees behind the pilot's position. In the three-dimensional geometry of aerial combat, where attacks develop in seconds and survival depends on seeing threats before they achieve firing solutions, 60 degrees of blocked vision represents a death sentence. Kartveli's original design calculations prioritized other factors. The P-47's massive radial engine demanded cooling airflow that shaped the fuselage cross-section. The turbo supercharger installation, buried in the aircraft's belly and connected to the engine through ducting that ran along both sides of the cockpit, dictated internal arrangement, the structural strength required to survive high-speed dives, and violent combat maneuvers drove decisions about fuselage shape and thickness. Pilot visibility, while acknowledged as important, competed against engineering constraints that seemed immovable. The razorback canopy configuration emerged from those competing priorities as a compromise that appeared acceptable during development. The sliding canopy provided adequate forward visibility for formation flying and bombing runs. Side panels offered reasonable situational awareness during turning engagements. The rear-view mirror mounted in the canopy gave pilots at least theoretical ability to monitor their 6 o'clock position. In peacetime testing, where threats arrived from predictable angles at known times, the visibility package seemed sufficient. Combat operations over occupied Europe demonstrated the fatal flaw in that assessment. German fighter tactics evolved specifically to exploit the P-47's blind sector. Luftwaffe pilots learned to approach razorback Thunderbolts from directly astern, using the American aircraft's own fuselage as concealment until achieving close-range firing position. The tactic worked with devastating efficiency. P-47 pilots, flying aircraft that could outrun, outdive, and outshoot almost anything in the German inventory, died without ever seeing their killers. By summer of 1943, the statistics became impossible to ignore. The 8th Air Force's Thunderbolt squadrons were suffering losses that correlated directly with poor rearward visibility. Pilots complained about the razorback configuration in after-action reports, intelligence debriefings, and official recommendations routed through command channels. Squadron commanders noted that experienced pilots survived by constantly weaving their aircraft during combat, sacrificing formation, discipline, and fuel efficiency to check their blind spots through aggressive maneuvering. The solution already existed, developed by British engineers confronting the identical problem with their own fighter aircraft. The Hawker Typhoon, a ground attack fighter plagued by similar visibility limitations, had recently received a revolutionary canopy design that eliminated the traditional framed structure entirely. Instead of the car door-style canopy that restricted rearward vision, British designers created a one-piece blown perspex bubble that wrapped around the pilot's position, providing near-complete visibility in all directions. The concept represented a radical departure from conventional aircraft canopy design. Traditional canopies used heavy framing to support individual glass panels, accepting restricted visibility as the price for structural integrity. The bubble canopy eliminated framing by forming the entire canopy from a single piece of transparent material, shaped through heated molding processes that created compound curves impossible with flat glass panels. The result offered pilots an unobstructed view approaching 360 degrees, transforming the cockpit from a partially enclosed workspace into a transparent observation platform. American intelligence officers forwarded photographs and technical descriptions of the Typhoon's bubble canopy to Republic Aviation during early 1943. The reports emphasized the dramatic improvement in pilot situational awareness, the elimination of structural blind spots, and the positive reception among British pilots who flew both configurations. For Focke-Wulf and his engineering team, the British innovation represented both solution and challenge. Solving the P-47's visibility problem required not just copying the Typhoon's canopy design, but adapting it to an aircraft with fundamentally different dimensions and structural requirements. The P-47's fuselage measured 40 inches wide at the cockpit, substantially broader than the Typhoon's narrower profile. Creating a bubble canopy for the Thunderbolt demanded forming transparent material into shapes larger than anything previously attempted in aircraft production. The compound curves required to provide visibility while maintaining aerodynamic efficiency pushed existing manufacturing techniques to their limits. American industry possessed the machinery and expertise for mass-producing conventional framed canopies. No one had attempted high-volume bubble canopy production, but Republic Aviation had built its business on solving engineering problems that other manufacturers considered impossible. The company that designed a 7-ton fighter around a turbo supercharger installation most engineers thought impractical, understood how to transform radical concepts into production reality. Kartvelli's team began preliminary design work on a bubble canopy installation for the P-47 during spring of 1943, working from British technical data and their own combat experience feedback. The engineering challenges extended beyond canopy design into fundamental aircraft architecture. The P-47's razorback configuration derived its name and shape from the tall fuselage spine that ran from the cockpit to the vertical stabilizer. That structure housed radio equipment, control cables, oxygen systems, and structural members that contributed to the aircraft's exceptional strength. Cutting down the fuselage to accommodate a bubble canopy meant relocating or rerouting equipment, redesigning load-bearing structures, and potentially compromising the very qualities that made the Thunderbolt famous for surviving battle damage. Wind tunnel testing revealed additional complications. Removing the razorback spine altered the P-47's aerodynamic characteristics in ways that affected directional stability. The tall fuselage acted as a vertical surface that helped maintain straight flight during high-speed operations. Cutting it down reduced that stabilizing influence, creating a tendency toward yaw oscillations that could make the aircraft difficult to control during combat maneuvering. The wing solution required, adding a dorsal fin extension ahead of the vertical stabilizer, restoring keel area without reintroducing the visibility problems the modification aimed to eliminate. Structural analysis identified weight distribution changes that required careful management. The razorback spine contributed approximately 150 pounds to the P-47's empty weight. Removing that material offered the opportunity to increase internal fuel capacity, addressing another persistent complaint from combat pilots about the Thunderbolt's limited range. But relocating fuel tanks within the fuselage demanded new plumbing runs, revised center of gravity calculations, and modified structural supports to handle different loading conditions. Republic Aviation's leadership faced a strategic decision that balanced engineering perfectionism against operational urgency. Pursuing a complete redesign of the P-47's fuselage would require months of development work, extensive testing, and gradual introduction to avoid disrupting existing production lines. Combat operations over Europe could not wait for that methodical process. 8th Air Force bomber losses were climbing as German fighter opposition intensified. Every week of delay in improving the Thunderbolt's combat effectiveness translated to additional American casualties. The solution emerged as a two-track approach. Republic would continue production of Razorback P-47Ds to maintain delivery schedules, while simultaneously developing the bubble canopy variant for future introduction. A single aircraft, P-47D5 serial number 42-8702, would serve as the test platform for proving the concept's viability before committing to production modifications. During July 1943, that aircraft entered Republic's experimental facility at Farmingdale for the most significant modification in the P-47's development history. Engineers removed the razorback fuselage spine from behind the cockpit, cutting the structure down to just inches above the pilot's shoulders. The modification created an entirely different visual profile, transforming the Thunderbolt from its characteristic jug-like silhouette into something sleeker and more modern. The bubble canopy itself arrived from Britain, shipped across the Atlantic as part of the technical cooperation that characterized Allied aircraft development during the war. The Hawker Typhoon canopy did not fit the P-47's wider fuselage without modification, but it provided essential reference for American manufacturers learning bubble canopy production techniques. Republic's engineers used the British example to develop specifications for a Thunderbolt-specific canopy, scaled to the P-47's dimensions, and engineered to integrate with American production methods. Installing the bubble canopy required solving problems that extended beyond simple mechanical fit. The transparent material, while offering superior visibility, provided no inherent structural strength. The canopy needed to withstand air loads at speeds approaching 500 miles per hour, maintain integrity if struck by battle damage, and operate reliably through thousands of opening and closing cycles. The mounting system demanded precise tolerances that allowed smooth operation while preventing leaks from the pressure differential created by the P-47's turbo-supercharger system. The modified aircraft, redesignated XP-47K, completed its first flight during summer 1943. Test pilot Mike Gerschler climbed into the modified cockpit and immediately recognized the transformation. Where the razorback configuration had forced constant head movement to check blind sectors, the bubble canopy provided instantaneous visibility in almost every direction. Roll the aircraft left or right, and the transparent canopy revealed the sky from horizon to horizon. Look back over either shoulder, and the view extended past the tail surfaces to empty air beyond. Difference transcended mere convenience. In the three-dimensional combat environment where situational awareness meant survival, the bubble canopy fundamentally altered the tactical calculus of air combat. German fighters approaching from the rear quarter no longer benefited from a guaranteed blind sector. Allied pilots could spot threats earlier, react faster, and maintain better formation cohesion without sacrificing vigilance for positional discipline. Flight testing confirmed the modification's success, while revealing the predicted stability issues. The XP-47K exhibited slight directional instability during certain flight regimes, manifesting as a tendency to wander off heading during high-speed flight. The problem proved manageable rather than dangerous, but it validated wind tunnel predictions about reduced keel area. Aerodynamics engineers returned to their calculations, developing the dorsal fin extension that would restore stability without compromising visibility. A second, prototype, designated XP-47 liters, incorporated both the bubble canopy and increased internal fuel capacity. Raising fuel load from 305 gallons to 370 gallons extended the P-47's combat radius significantly, addressing range limitations that had prevented Thunderbolts from escorting bombers deep into Germany. The combination of improved visibility and greater endurance created what amounted to a substantially enhanced combat aircraft, achieving through focused modifications what a complete redesign might have delivered at far greater cost in time and resources. Republic Aviation's management approved production implementation during late 1943, rather than designating the bubble canopy aircraft as a new variant, which would have disrupted logistics and training pipelines. The decision treated it as a continuation of the existing P-47D series. The designation would simply advance to the next production block number, with P-47D-25 becoming the first bubble canopy Thunderbolt to roll off Farmingdale's assembly lines. Production planning targeted May 1944 for initial deliveries to combat units. The timeline reflected not just engineering development but the practical challenges of retooling production lines while maintaining output. Republic's Farmingdale facility produced Thunderbolts at a rate approaching 4 aircraft daily. Modifying that production flow to accommodate bubble canopy installation required coordinating changes across hundreds of assembly stations, training thousands of workers in new procedures, and qualifying new suppliers for canopy manufacturing. The canopy manufacturing process itself represented a significant technical challenge. Creating bubble canopies demanded specialized equipment and processes that few American companies had mastered. The transparent material, typically methyl methacrylate marketed under trade names like plexiglass, required heating to precise temperatures before being vacuum-formed over male molds shaped to the canopy's compound curves. Cooling had to occur gradually to prevent internal stresses that would create optical distortions or structural weaknesses. Quality control standards for bubble canopies exceeded normal aircraft component requirements. Optical clarity mattered as much as structural integrity. Distortions that might pass unnoticed inside windows could fatally mislead pilots attempting to judge distances during air combat. Scratches, crazing, or discoloration that developed during service would degrade the visibility advantage the canopy provided. Manufacturers had to develop inspection procedures and handling protocols that ensured consistently high quality across thousands of production units. Republic Aviation contracted with multiple suppliers to build production capacity adequate for the anticipated demand. The company's own facilities at Farmingdale and Evansville, Indiana, would consume bubble canopies as fast as manufacturers could deliver them. Additional contracts supported field modification kits that would allow existing Razorback P-47 seconds to receive bubble canopy upgrades, extending the improvement to aircraft already in combat service. As production preparations advanced through winter 1943 and into spring 1944, combat operations over Europe intensified toward the climactic confrontations that would determine the air war's outcome. 8th Air Force bomber formations penetrated deeper into Germany, striking industrial targets that supported the Nazi war machine. German fighter opposition grew correspondingly fiercer as Luftwaffe commanders committed their dwindling resources to defending critical facilities. P-47 Thunderbolt pilots flew escort missions that pushed their aircraft to the limits of internal fuel capacity, fighting running battles against German interceptors while shepherding vulnerable bomber formations through defended airspace. The Razorback configuration's visibility limitations extracted a steady toll, measured in aircraft lost and pilots killed. Each casualty report reaching Republic Aviation's engineering department reinforced the urgency of getting bubble canopy Thunderbolts into combat as quickly as possible. The first production P-47D 25 seconds emerged from Farmingdale's assembly lines during April 1944, painted in standard olive-drab camouflage, with the distinctive new profile that marked them as different from all previous Thunderbolts. The bubble canopy transformed the aircraft's appearance as dramatically as it improved pilot visibility. Where Razorback P-47 seconds looked massive and purposeful, the bubble-top variant appeared sleeker and more aggressive, despite maintaining identical dimensions forward of the cockpit. Ground crews nicknamed the new aircraft Superbolts in recognition of their enhanced capabilities. Pilots transitioning from Razorback Thunderbolts to bubble canopy variants reported the change. Felt like moving from a tunnel into open air. The psychological impact matched the tactical advantage. Confidence increased, knowing that German fighters could no longer approach undetected from behind. Formation discipline improved when pilots could maintain visual contact with wingmen through complete turns, rather than losing sight during specific maneuvers. Combat units began receiving P-47D 25 seconds during May 1944, timing that aligned perfectly with the final preparations for Operation Overlord, the Allied invasion of Normandy. The 8th Air Force's fighter groups that would provide air cover for the invasion fleet and support ground operations needed every advantage available. Bubble canopy Thunderbolts offered capabilities that seemed almost custom-designed for the coming campaign. The transformation of American fighter aviation was about to accelerate beyond anything the pre-war generation of aircraft designers had imagined possible. What began as a simple attempt to eliminate a blind spot would evolve into a fundamental reimagining of what fighter pilots could see, how they fought, and ultimately, whether they survived the war that tested every assumption about aerial combat. The bubble canopy represented not just an engineering solution, but a philosophical shift in how Americans approached the problem of keeping pilots alive while accomplishing their missions. Lieutenant Colonel David Schilling leveled his P-47 D-25 at 28,000 feet over the French coast, the morning sun of June 6, 1944, reflecting off the bubble canopy that wrapped his cockpit in transparent protection. Through the clear perspex, visibility extended in every direction with a completeness that would have seemed impossible to pilots who had flown Razorback Thunderbolts just months earlier. Below, the English Channel churned with the largest invasion fleet in human history, thousands of ships carrying Allied forces toward the beaches of Normandy. Schilling rolled his aircraft left, checking his 6 o'clock position with a casual glance over his shoulder. No frantic neck craning, no desperate attempts to peer around the Razorback spine that had blocked rear vision on earlier Thunderbolts. The bubble canopy transformed situational awareness from constant effort into natural perception. German fighters approaching from behind would be visible immediately, their presence announced by visual contact rather than by the impact of cannon shells. The transformation had arrived with shocking speed. P-47D 25 seconds began reaching 8th Air Force squadrons during late May 1944, timing that aligned almost perfectly with final preparations for Operation Overlord. Ground crews worked around the clock, fitting the new aircraft with invasion stripes, the distinctive black and white bands that identified Allied aircraft to nervous anti-aircraft gunners who would be shooting at anything approaching the invasion fleet. Pilots, transitioning from razorback Thunderbolts, reported the change felt like emerging from a cave into daylight. The tactical advantages manifested immediately during combat operations. Bubble canopy pilots maintained visual contact with their wingmen through complete 360-degree turns, eliminating the coordination gaps that had plagued earlier formations. Formation discipline improved because pilots could monitor position relative to flight leaders without losing awareness of threats from other directions. The psychological confidence boost matched the tactical enhancement. Knowing that German fighters could not approach undetected from the rear quarter allowed pilots to focus on offensive operations rather than defensive vigilance. On D-Day itself, Allied air supremacy proved so complete that Luftwaffe opposition barely registered. Only 2 German fighters reached the invasion beaches, both shot down before accomplishing anything meaningful. 26 additional German aircraft died attempting to penetrate the defensive umbrella maintained by thousands of Allied fighters, including hundreds of P-47 seconds, providing close air support to troops struggling ashore through German resistance. The bubble canopy Thunderbolts excelled in the low-level ground attack role, their pilots able to spot targets, track friendly forces, and maintain formation cohesion while operating in the chaotic environment just above the battlefield. The days following D-Day transformed the European air war from strategic bombing escort to direct battlefield support. P-47 pilots learned to identify German armor by visual signature, to distinguish Wehrmacht trucks from Allied vehicles at speeds approaching 400 miles per hour, to coordinate strikes with forward air controllers who marked targets with colored smoke. The bubble canopy made these demanding tasks manageable by providing the visibility needed to operate safely at low altitude while scanning for both targets and threats. Captain William Colgan led a flight of 3 bubble-top P-47Ds up the Rhône River Valley on August 28, 1944, searching for targets of opportunity as Allied forces advanced through southern France following Operation Dragoon, the invasion launched 2 weeks earlier. The bubble canopy allowed Colgan to spot the German column from miles away, 30 miles of vehicles proceeding 2 and 3 abreast as they retreated northward from the Allied advance. The ensuing attack demonstrated both the P-47's devastating ground attack capability and the bubble canopy's contribution to successful low-level operations. Colgan's flight made repeated passes along the column, their 850 caliber machine guns per aircraft raking trucks, half-tracks, and support vehicles, while the pilots maintained constant visual awareness of their positions relative to each other and to the intense defensive fire rising from the German convoy. The bubble canopy allowed them coordinate attacks, avoid collisions during the violent maneuvering required for strafing runs, and spot threats before they became fatal. But the ground attack role extracted costs that demonstrated the fundamental difference between air-to-air combat and the deadly business of attacking defended targets. On July 20, 1944, Colonel Francis Gabreski, the 8th Air Force's leading ace with 28 victories, all scored in P-47 seconds, flew a low-level strafing mission against German aircraft at an airfield near Koblenz. His bubble-top P-47D descended toward a line of Heinkel-He, 111 bombers parked along the runway's edge, his 8 machine guns preparing to deliver destruction. The propeller struck ground during the attack run, the massive 4-bladed assembly shattering against earth that should have remained safely below. Gabreski's Thunderbolt bellied in hard, the tough airframe absorbing punishment that would have killed a lighter aircraft but leaving the pilot alive to spend the war's remaining months as a prisoner. The bubble canopy provided perfect visibility during the crash landing, allowing Gabreski to control the uncontrollable, to guide 7 tons of crippled fighter through a survivable impact sequence. The incident highlighted a persistent truth about ground attack operations. All the visibility in the world could not eliminate the fundamental danger of flying low and slow through defensive fire from ground-based weapons ranging from rifles to 88mm anti-aircraft guns. The bubble canopy helped pilots see threats and targets, coordinate attacks, and avoid collisions. It did not make them invulnerable to the concentrated firepower that met every strafing run over defended territory. The 56th Fighter Group, better known as Zemke's Wolfpack after its legendary commander Colonel Hubert Zemke, became the proving ground for an important strategic decision about American fighter aircraft. As 1944 progressed, and the P-51 Mustang demonstrated superior range and performance in the long-range escort role, 8th Air Force leadership began converting fighter groups from Thunderbolts to Mustangs. The conversion made tactical sense. Mustangs could escort bombers all the way to Berlin and back, while even bubble-top P-47 seconds with increased fuel capacity struggled to match that endurance. But the 56th Fighter Group refused conversion. Zemke and his pilots had mastered the Thunderbolt, developed tactics that exploited its strengths while minimizing its limitations, and achieved an enviable combat record that included over 650 aerial victories by war's end. When offered P-51 seconds, the Wolfpack declined. They would fight the rest of the war in the aircraft they knew and trusted, the heavy, rugged, bubble canopy-equipped fighter that had brought them through hundreds of missions with survival rates other groups envied. The decision validated a fundamental truth about aircraft effectiveness. The best fighter was not necessarily the one with the highest top speed or longest range. The best fighter was the one that brought pilots home alive while accomplishing the mission. The P-47's bubble canopy, combined with its legendary toughness and devastating firepower, created a weapons system that pilots trusted with their lives. That trust translated into tactical effectiveness that raw performance specifications could never capture. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The bubble canopy's contribution to pilot survival became statistically demonstrable through careful analysis of combat loss reports. P-47 seconds, equipped with bubble canopies, showed measurably lower loss rates in air-to-air combat compared to razorback variants operating in similar tactical situations. The difference could not be attributed to pilot experience alone, since both configurations served simultaneously during the crucial months of summer 1944. The bubble canopy provided a concrete tactical advantage that translated directly into lives saved and missions completed. German fighter tactics evolved in response to the bubble canopy's widespread adoption. Luftwaffe pilots who had successfully hunted razorback P-47 seconds by approaching from directly astern found that tactics suddenly ineffective against bubble-top variants. The American pilots spotted threats earlier, reacted faster, and maintained better formation cohesion during defensive maneuvers. German fighter commands issued tactical guidance emphasizing different attack angles, but the fundamental challenge remained. American fighters with 360-degree visibility were simply harder to surprise and harder to kill. The production numbers told their own story about the bubble canopy's importance. Republic Aviation's Farmingdale and Evansville facilities built 7,179 bubble canopy P-47Ds between mid-1944 and war's end, compared to 9,530 razorback variants produced during the preceding 18 months. The shift represented not just improved design, but fundamental recognition that pilot visibility directly affected combat effectiveness. Field modification programs extended bubble canopy benefits to razorback aircraft already in service. Engineering teams developed retrofit kits that allowed squadron-level mechanics to cut down existing fuselages and install bubble canopies without returning aircraft to factory facilities. The modifications consumed resources and created temporary operational disruptions, but commanders accepted those costs because the tactical benefits justified the investment. An aircraft with better visibility was an aircraft more likely to survive and complete its mission. The Royal Air Force received 590 bubble-top P-47D 25 seconds designated Thunderbolt Mark IIs, comparing favourably to the 240 razorback P-47Ds they had operated earlier as Mark Is. RAF squadrons in Burma used the improved Thunderbolts for ground attack operations against Japanese forces, where the bubble canopy proved equally valuable in the Pacific Theatre's different tactical environment. Jungle flying demanded constant visual awareness of terrain, weather, and threats from multiple directions. The bubble canopy provided that awareness naturally, reducing pilot workload while increasing operational safety. By autumn 1944, the bubble canopy had become standard equipment on American fighter aircraft across all theaters. The P-51 Mustang adopted similar canopy designs, benefiting from manufacturing techniques Republic Aviation had refined during P-47 production. The principle extended beyond individual aircraft types to become fundamental doctrine. American fighters would provide pilots with maximum possible visibility because seeing threats before they killed you mattered more than almost any other performance characteristic. The engineering legacy of the bubble canopy development program influenced aircraft design for decades beyond World War II. Jet fighters emerging during the late 1940s and early 1950s universally adopted bubble canopy configurations, recognizing that pilot visibility remained critically important even as speeds increased beyond anything propeller aircraft could achieve. The F-86 Sabre, F-84 Thunderjet, and dozens of subsequent fighter designs incorporated lessons learned from the P-47's bubble canopy development. Manufacturing technology advances driven by wartime bubble canopy production created capabilities that supported entirely new industries after the war. The techniques for forming large compound curved transparent panels from acrylic materials found applications in commercial aviation, automotive design, and architectural glazing. The quality control processes developed to ensure optical clarity in aircraft canopies influenced manufacturing standards across multiple industries, where transparent materials demanded both structural integrity and visual precision. Colonel Zemke's P-47D Oregon's Britannia, bearing serial number 42-26413, reportedly became the first bubble canopy Thunderbolt to reach England during spring 1944. The aircraft served as Zemke's personal mount through the crucial months of D-Day and the subsequent Allied advance across France. Its bubble canopy bore witness to combat operations that helped decide the war's outcome, providing its pilot with visibility that earlier Razorback aircraft could never match. The aircraft was destroyed in a crash during December 1944, the kind of operational accident that claimed aircraft and sometimes lives throughout the war regardless of canopy configuration. But during its months of combat service, Oregon's Britannia demonstrated the bubble canopy's tactical value through successful completion of dozens of missions that might have ended differently with restricted visibility. Zemke survived the crash and continued flying, eventually scoring 17 3/4 aerial victories before war's end. The final accounting of the bubble canopy's contribution to Allied victory resists simple quantification. How many pilots survived because they spotted German fighters approaching from their 6 o'clock position? How many successful intercepts occurred because formation leaders maintained visual contact with their squadrons through complete tactical maneuvers? How many ground attack missions succeeded because pilots could coordinate strikes while maintaining awareness of defensive fire and terrain obstacles? The answers exist in scattered combat reports, pilot testimonies, and statistical analyses that hint at impacts too diffuse to capture in single dramatic moments. The bubble canopy did not win battles through spectacular individual achievements. It won battles by incrementally improving pilot effectiveness across thousands of missions, by reducing the constant background stress of flying aircraft with blind spots that enemies exploited, by transforming situational awareness from exhausting effort into natural perception. By May 8, 1945, when Germany surrendered and the European War ended, bubble canopy P-47 seconds had flown hundreds of thousands of sorties in support of operations that destroyed the Third Reich's military capability. They had escorted bombers to targets across occupied Europe, strafed German columns retreating from Allied advances, defended airspace over invasion beaches and supply routes, and demonstrated that American industrial capacity could solve tactical problems through systematic engineering development. The Pacific Theater's conclusion 3 months later, on August 15, 1945, brought final vindication of the bubble canopy design philosophy. P-47Ns, the ultimate Thunderbolt variant with extended range and bubble canopy as standard equipment, served in operations against Japan during the war's final months. Their pilots reported the same tactical advantages that European theatre aircrews had experienced. Better visibility meant better survival, better mission completion rates, and better overall combat effectiveness. The post-war analysis of fighter aircraft development identified the bubble canopy as one of several key innovations that transformed air combat during World War II. Alongside improvements in engine reliability, weapons effectiveness, and radar technology, the bubble canopy represented recognition that human factors mattered as much as mechanical performance. The pilot who could see threats and opportunities clearly would outperform the pilot flying a faster aircraft with restricted visibility. The lesson influenced American military aviation procurement for the jet age and beyond. Fighter specifications routinely included visibility requirements that mandated bubble canopy configurations or equivalent solutions. The principle extended to other aircraft types, including attack helicopters, reconnaissance platforms, and trainer aircraft where student pilots needed maximum visibility to develop proper situational awareness. The bubble canopy development program demonstrated how systematic engineering could address tactical deficiencies identified through combat experience. The process began with pilot complaints about razorback visibility limitations, progressed through evaluation of British innovations, continued with American adaptation and manufacturing development, and concluded with fleet-wide implementation that improved combat effectiveness across an entire air force. The timeline from problem identification to solution deployment measured approximately 18 months, remarkably rapid for such fundamental aircraft modification. That rapid development reflected both American industrial capacity and organizational willingness to implement improvements based on combat feedback. Other nations struggled to modify production aircraft designs mid-war, constrained by limited manufacturing capacity, bureaucratic resistance to change, or inability to gather and process combat lessons systematically. The United States built institutional systems that identified problems, developed solutions, and implemented changes while maintaining production rates that enemies could never match. The contrast between American and Axis approaches to fighter aircraft development illuminated fundamental differences in how nations prosecuted industrial warfare. Germany and Japan built technically sophisticated aircraft that pushed performance boundaries but struggled with reliability, maintainability, and production efficiency. The United States built aircraft that were good enough in performance while excelling at reliability, ease of maintenance, and production volume. The bubble canopy epitomized that philosophy. It did not make the P-47 faster or more maneuverable. It made American pilots more effective by solving a human factors problem through straightforward engineering. Alexander Kartveli, the designer who created the P-47 Thunderbolt from first principles and then improved it through the bubble canopy development, embodied the immigrant contribution to American technological achievement during World War II. Born in Georgia when it was part of the Russian Empire, educated in Paris, he brought European engineering sophistication to American industrial capacity. The combination produced aircraft that helped win the war and influenced aviation development for generations. The Republic Aviation Company that built over 15,000 Thunderbolts during the war years demonstrated American manufacturing capability at its peak. The ability to design, test, and implement major modifications like the bubble canopy, while maintaining production rates that delivered hundreds of aircraft monthly, showed industrial organizational competence that enemies could observe but never match. Every bubble canopy P-47 that rolled off production lines represented victory in the industrial arithmetic that ultimately determined the war's outcome. The human stories behind the statistics resonated most powerfully in veterans' accounts recorded decades after the fighting ended. Pilots who had flown both Razorback and bubble canopy Thunderbolts universally praised the improved visibility, describing it as transformative rather than incremental. The ability to see approaching threats, to maintain formation awareness, to coordinate attacks while monitoring defensive fire, made dangerous missions survivable and difficult missions achievable. Those testimonies carried weight beyond individual experiences. They represented collective wisdom from men who had wagered their lives on aircraft performance characteristics who had trusted engineering decisions with survival itself, and who had returned home to report what worked and what did not. The bubble canopy worked. It solved a real tactical problem through practical engineering, implemented rapidly enough to affect the war's outcome and thoroughly enough to become standard equipment. The legacy extended into the jet age and beyond, as bubble canopies became universal on fighter aircraft regardless of nation or design philosophy. Soviet fighters adopted bubble canopies. British fighters used bubble canopies. Every nation-building military aircraft recognized that pilot visibility mattered fundamentally to combat effectiveness. The principal Alexander Kartveli and his Republic aviation team proved with the P-47 Thunderbolt became accepted wisdom that influenced aircraft design into the 21st century. Modern fighter aircraft, with their sophisticated sensor systems and helmet-mounted displays, still incorporate bubble canopy designs because human vision remains irreplaceable for certain combat tasks. The Mark I eyeball, as pilots called it, provided capabilities that no electronic system could fully replicate. Situational awareness, built from direct visual observation, operated faster and more reliably than any technology available during World War II or for decades afterward. The P-47 Thunderbolt's bubble canopy represented more than engineering innovation. It demonstrated institutional capability to identify problems through combat feedback, develop solutions through systematic research and development, and implement improvements through industrial production at scale. That capability, repeated across dozens of weapons systems and hundreds of tactical improvements, gave Allied forces advantages that accumulated into overwhelming superiority. The final tally showed P-47 Thunderbolts destroying more Luftwaffe aircraft than any other Allied fighter type. Over 3,500 German aircraft shot down in air-to-air combat. They demolished 170,000 locomotives, rail cars, armoured vehicles, and trucks during ground attack operations. They flew over 746,000 sorties across all theatres, supporting operations from D-Day through the final defeat of Nazi Germany and Imperial Japan. Those numbers represented aggregate effects from thousands of individual missions flown by pilots who trusted their aircraft to bring them home. The bubble canopy contributed to that trust by solving the fundamental problem of visibility, by eliminating blind spots that enemies exploited, by providing situational awareness that meant the difference between survival and death. Not every mission succeeded. Not every pilot survived. But the bubble canopy gave them better odds, and in combat, better odds meant everything. The morning sun still reflects off restored P-47, Thunderbolts displayed in museums and flying at air shows, their bubble canopies gleaming with the same clarity that protected pilots 8 decades ago. Visitors can climb into the cockpit, settle into the seat that felt like a lounge chair, and look around through transparent panels that wrap nearly 360 degrees. The view explains itself immediately. This is what situational awareness looked like when engineering solved tactical problems through practical innovation. The story of the P-47's bubble canopy reminds us that wars are won through accumulated advantages rather than single decisive innovations. The canopy did not revolutionize air combat. It incrementally improved pilot effectiveness across thousands of missions. But those incremental improvements, multiplied across entire air forces and sustained over years of combat, determined outcomes. The pilot who saw threats before they killed him survived to fight again. The pilot who survived fought more effectively. The more effective pilot contributed to victory. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.